According to the National Electrical Code, specifically Article 300.3, C1, conductors of different systems such as 5 kilovolt and 600 volt should not occupy the same raceway or cable tray. This requirement exists unless special permission is granted by the authority having jurisdiction. However, there is an exception. Conductors of different systems are permitted to occupy the same raceway or cable tray if they are separated by a solid barrier. The interlocked armor of 5 kilovolt cables does not meet the requirements of a solid barrier as defined in the National Electrical Code. Therefore, it cannot be used to separate different systems in a cable tray. Based on the National Electrical Code requirements, it is not permitted to run 5 kilovolt cables in the same tray with 600 volt cables without a tray divider. The interlocked armor of the 5 kilovolt cables does not meet the definition of a solid barrier and cannot be used to separate the systems. Beyond the safety concerns raised by the code, there are also practical considerations to support the use of a tray divider. Firstly, high voltage cables can induce voltage into adjacent low voltage cables, potentially damaging equipment or creating hazardous situations. Secondly, in the event of a ground fault, the absence of a barrier can allow the high ground current to flow through the low voltage cables, tripping circuit breakers and causing unnecessary downtime. A tray divider simplifies maintenance and repair work by providing clear separation between the different systems. The National Electrical Code, often abbreviated as NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It is developed and updated every 3 years by the National Fire Protection Association, ensuring it remains relevant to evolving technologies and safety standards. Article 300 within the NEC addresses wiring methods, providing general requirements for wiring installations. Section 300.3 specifically focuses on the use of conductors of different systems within the same enclosure or raceway. The prohibition of mixing different voltage systems, such as 5 kilovolt and 600 volt, in the same raceway or cable tray without a solid barrier is rooted in safety. The potential for high voltage to energize lower voltage systems poses a significant risk of electrical shock, fire, and equipment damage. The exception allowing different voltage systems in the same enclosure or raceway when separated by a solid barrier provides a means to mitigate these risks. A solid barrier effectively isolates the different voltage systems, preventing the transfer of electrical energy and maintaining the integrity of each system. The definition of a solid barrier is crucial. It must be a physical partition that is sufficiently robust and non-conductive to withstand the voltage stresses and environmental conditions present in the installation. Interlocked armor, while providing mechanical protection to the cable, does not meet the criteria of a solid barrier. It is not designed to prevent the transfer of electrical energy between the high voltage and low voltage systems. The authority having jurisdiction, often referred to as the AHJ, plays a critical role in enforcing the NEC and ensuring electrical safety. The AHJ may grant special permission to deviate from the code in specific circumstances, but only when it can be demonstrated that equivalent safety is provided. In the case of mixing different voltage systems, the AHJ would likely require detailed engineering analysis and documentation to justify any deviation from the requirement for a solid barrier. The practical considerations of voltage induction, ground fault protection, and maintenance further support the need for a tray divider or solid barrier. Voltage induction occurs when a high voltage cable generates an electromagnetic field that induces a voltage in nearby low voltage cables. This induced voltage can damage sensitive electronic equipment, create false signals, and pose a shock hazard to personnel. A solid barrier minimizes voltage induction by increasing the distance and reducing the electromagnetic coupling between the high voltage and low voltage cables. Ground fault protection is another critical safety measure. A ground fault occurs when a conductor comes into contact with a grounded surface, such as the metal enclosure of a cable tray. In a high voltage system, a ground fault can result in a large fault current flowing through the grounding system. If low voltage cables are present in the same tray without a barrier, the fault current can flow through these cables, potentially damaging them and creating a fire hazard. A solid barrier prevents the fault current from propagating to the low voltage cables, ensuring that the ground fault protection system operates correctly and safely. Maintenance and repair are also simplified by the use of a tray divider. When working on one system, the divider provides a clear physical separation from the other system, reducing the risk of accidental contact with energized conductors. This improves safety and efficiency for electrical workers. In summary, the National Electrical Code prohibits the mixing of different voltage systems, such as 5 kV and 600 volt, in the same raceway or cable tray without a solid barrier. Interlocked armor does not meet the requirements of a solid barrier. Practical considerations of voltage induction, ground fault protection, and maintenance further support the need for a tray divider. Adhering to these code requirements and best practices ensures the safety of people and property from electrical hazards. When dealing with electrical installations involving different voltage systems, always consult the latest edition of the National Electrical Code and consult with qualified electrical engineers and the authority having jurisdiction to ensure compliance and safety. The NEC provides a comprehensive set of rules and guidelines, but it is essential to understand the underlying principles and apply them correctly to specific situations. The potential hazards associated with high-voltage systems necessitate a cautious and meticulous approach to design, installation, and maintenance. Failure to follow the code and best practices can have serious consequences, including electrical shock, fire, equipment damage, and even loss of life. Therefore, it is imperative to prioritize safety and ensure that all electrical work is performed by qualified and experienced professionals. In addition to the requirements of the NEC, other standards and regulations may also apply to electrical installations. These may include local building codes, industry standards, and manufacturers' recommendations. It is essential to be aware of all applicable requirements and ensure that the installation complies with all relevant regulations. The complexity of electrical systems and the potential hazards involved make it essential to seek expert advice when needed. Consulting with qualified electrical engineers, inspectors, and other professionals can help ensure that the installation is safe, reliable, and compliant with all applicable requirements. The cost of hiring qualified professionals is often outweighed by the benefits of reduced risk, improved safety, and increased reliability. In conclusion, the National Electrical Code provides clear guidance on the separation of different voltage systems in electrical installations. Adhering to these requirements and best practices is essential for ensuring the safety of people and property. The use of a solid barrier, such as a tray divider, is crucial for preventing voltage induction, mitigating ground fault hazards, and simplifying maintenance and repair work. Always consult the latest edition of the NEC and seek expert advice when needed to ensure compliance and safety. The information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. Electrical installations should always be designed, installed, and inspected by qualified professionals. It is important to remember that electrical safety is a shared responsibility. Everyone involved in the design, installation, operation, and maintenance of electrical systems has a role to play in preventing accidents and ensuring safety. By following the code, adhering to best practices, and seeking expert advice when needed, we can create a safer environment for everyone. The NEC is not just a set of rules, it is a framework for promoting electrical safety and protecting people and property from harm. By understanding and applying the principles of the code, we can contribute to a safer and more reliable electrical infrastructure. The ongoing development and refinement of the NEC reflect the commitment of the electrical industry to continuous improvement in safety standards. As new technologies emerge and our understanding of electrical hazards evolves, the code will continue to adapt to meet the challenges of the future. It is our responsibility to stay informed about the latest updates to the NEC and to apply them diligently in our work. Electrical safety is not a static concept, it is an ongoing process of learning, adaptation, and improvement. By embracing this mindset, we can create a culture of safety that protects us all from the hazards of electricity. The principles of electrical safety extend beyond the specific requirements of the NEC. They encompass a broader set of values and behaviors that prioritize safety in all aspects of electrical work. These include a commitment to quality workmanship, our respect for the potential hazards of electricity, and a willingness to learn from mistakes. By embodying these values, we can create a safer and more sustainable electrical infrastructure for future generations. The NEC provides a foundation for electrical safety, but it is up to each of us to build upon that foundation and create a culture of safety that permeates all aspects of our work. By working together, we can make a difference and ensure that electricity is used safely and responsibly.